we should be done with all of our regular proof stuff that we'll be doing for the most part after chapter 4. There are very few proofs that are in chapter 5 or chapter 6. That becomes a little bit more algebra again. Excuse me. We're gonna start chapter 3 stuff, like the end of 2 and beginning of 3 is kind of all the same. We'll start with that stuff towards the end of the week. And then it'll only take us a couple of weeks to get through that. We will probably be on our way with the triangle proofs by the by the second week of November. You know, that short first week of where parent-teacher conferences are. That's probably when we'll first start our triangle proofs. And we'll do triangle proofs pretty much the entire time through November and maybe into the very beginning of December. I believe Christmas break, winter break is a little bit different this year because I think it starts on like a Wednesday. I think it goes, because the way the day of Christmas backs up to, and New Year's. So my best guess, yeah, because we'll be in proofs probably in this neighborhood here for triangles, chapter 4 about there. Yeah, because Christmas is on that Sunday. I believe we go to school through Wednesday, and then we come back on the 4th. So it's broken up a little bit differently this year. I haven't seen it like that in a long time. But yeah, we should be able to finish. We should easily be able to finish all the triangle proofs well before Christmas, probably somewhere in that second week of December. Because then chapter 5 only takes like 6-7 days to get through. It's pretty quick. So, when you are working on proofs that you have to write up and work through that will be on your own, you have to kind of start out the same way each and every time. And that way is always going to be to do what do you think? Givens. Make sure you have givens. Make sure you have your progression charts out. Make sure you have your reason banks out so you can look and reference back and forth. So you get an idea of what it exactly is that you're going to be doing. What are you looking to be able to do? What are you trying to come up and accomplish? Another thing that you're going to start to see is that most of our proofs, whether or not they are segments or angles, they're kind of the same thing. Because you really only know how to do a few things. Segment addition, angle addition, things like that. Those are the only ones that you really are being able to work with. Excuse me. So let me move this bit of a triangle over a little bit so I have a bit more space. And then kind of go back and start looking at what information we know and what information we have to be able to show. So according to our one and only given statement, we're given that AB equals DC. We know that these two guys are going to be equal to one another. Anytime you have given stuff, make sure you mark your diagram. It'll help you out tremendously so that way you can see where in the world you're going to go with it. Okay? Now, what they want you to show is they want you to show that AC is going to be congruent to BD or DB. Now, what I want you guys to notice is that that larger segment is now made up of two smaller ones, isn't it? It has some bit of an overlap. See how it has that overlap here of BC for both of them? When that happens, when you start to see that, which we've done with angles as well, what I want you to do is think of this. True or false? Does 4 equal 4?
True.
All right. Does 5 equal 5?
True.
Yes. Does 4 plus 5 equal 4 plus 5?
Yes.
Yeah. What did I do? Well, I have 4 equal to 4, 5 equal to 5, but what did I do from this step to this step? Add pop equal. I added the same thing to both sides. I added this 5 to both sides of an equal sign, and it didn't change. Isn't that the same idea with segments? If you start thinking about it, if you start with segment AB, you know it also equals CD. If I add the same thing to them that's equal, Wouldn't those result pieces still be equal? The same idea. It's the exact same idea. But remember, when you're dealing with segments, one of the things you have to do is you have to define that something's there. Do you remember how you define something's there? Why can I say this? It should be on that sheet. Very good. It's reflexive. Remember, guys, the reflexive property is there for when you have to define something. Whenever you have to show that something is there. Whenever you have this overlap scenario, whether it's going to be with segments or with angles, it's the same thing. Just one's an angle and one's a segment. Whenever you have that middle overlap, you're going to want to try to remember that you have to define that middle overlap. Okay? So the reason that I can do that is because of the reflexive property. Okay? Now, go along with the lines of here. 4 equals 4 was given, 5 equals 5 is because it's reflexive. Adding the same thing to both sides when equal was what?
We started a second ago.
What is it? Add prop equal. So we can do AB. By adding that same value to both sides of the equation, it doesn't change it because that segment of BC is itself. Same idea. 4 is 4, 5 is 5. 4 and 5 equals 4 and 5. It always will work that way. And it's the same scenario every time that you see this come up. Whether it's with segments you got to add a middle to, or with angles you have to add a middle to. You do the same thing. Okay. Now I want you to think about, on both sides of that equal sign, you have 2 smaller segments. You agree? What do those 2 smaller segments add up to equal? A bigger segment. These 2 smaller segments also add up to equal a bigger segment. So how would you rewrite that out? Well, what does AB plus BC equal? It's AC. It tells you AB in this is that whole thing. Going the other way. When I add those 2 together, what do you get? Why, hello! How are you guys? Did they make you walk back today?
No, the bushes forgot us.
Oh. It would have been a lot funnier if we said, yeah, I don't walk. Those jerks.
By the time we got here, we've been like 12 hours.
I collected the packet stuff that we were doing last week. If you guys just want to get that out, I'll grab it for you in here in a second, okay? This one equaled DB. Now, for both of these, I used the exact same reason. Segment addition. Very good. Both of those were segment addition. All I had you guys doing was the top and then the back one. Okay.
I put no home on my board, and then I said I switched it, and I didn't put it back.
Now, do I have? Oh, you're good.
I can tell you better.
If you guys take a look now, those last 3 steps are kind of the same thing we always wind up with, whether they're segments or angles or whatever. In where it said, where we have the add prop equal, we had 2 smaller segments equal to 2 smaller segments on both sides. The next 2 steps were saying that those 2 smaller segments add up to equal something different. 2 smaller segments add to something different. So whenever you see this pattern that you have 2 things equal to 2 other things, what can you always say about the other things? They're equal. Very good. They have to be. What's the property? Substitution. Guys, this is the same step over and over again. When 2 things are equal to each other, and then you can rewrite them as other letters, You just substitute them in for one another. That's it. Knowing that AB and BC, AB plus BC, knowing that these two guys are equal to each other, when I rewrote them here and here, that just means that these have to be equal to each other. That's all it is. Putting something in for something else. And what's the last thing you gotta do? Change it to clear red. And your reason is?
Oh, you're gonna, down
And that's what these look like. They're all kind of the same.
I get confused by these ones.
By which ones?
These ones, I don't know, like, if you explain it to me, like, I know exactly what to do, but like, when I look at above and stuff.
And this comes up all the time, because I know that they're not easy, especially the first few that you do. But you guys have to trust the fact that this idea of using this progression sheet, the idea that you have basically all of your what to do's and why's right here, and also the fact that we've done, I don't know, 15 or so of these, and like I've been saying, there's only so many of these things out there. We've probably done one that's eerily similar to. By going back and forth and looking at your notes, looking at the progression sheet, looking at the reason banks, I guarantee you're going to find something that looks just like what you're trying to figure out. It's being able to flip back and forth the papers and looking stuff up. Okay? Being resourceful. Okay? We are given that you have AB is perpendicular to BC. We're given that angle 2 equals angle 3. And then we have to prove that angle 1 and angle 3 equal 90. Again, as you go through this, if you start with the idea of what does that mean when you're perpendicular, well, the easiest thing to think about is, well, what does my progression sheet say? Thanks, Maggie. Get up too fast here. Sorry, guys. You're going to write this down. So when you go back and you look at your progression sheet, and guys, if you don't have your progression sheet out, make sure you get it out. So that way you can, when we do these examples in class, you can go into reference what they look like and what you're supposed to be looking for. Because you'd be surprised at how many answers are on the progression sheet. Like, most of them. So according to our fancy schmancy progression sheet, what does it say to do when you are perpendicular? I think we had two different things we can say, doesn't it? I think it says state the right angles that are formed. Now, did we put a little footnote in there about one angle versus two angles? I think we did, didn't we? Did we?
That was for right angles.
For right angles? Okay. But when you think about with perpendicular, in this example here, do we have, according to our diagram, is it just going to be one angle or two? There's two right angles there?
No, there's
One. Now, the reason why I'm saying that there's just one is because look at the diagram. They're saying that you got like angles 1 and 2 would have to add up to equal 90. Do you agree? Because you have a right angle at ABC because AB is perpendicular to BC. So, it's simple idea of reading the progression and filling in blanks. So if we start, AB is perpendicular to BC. Obviously, that's given. According to your sheet, it says to state the right angles that are formed. In this case, I only have really one right angle to worry about, angle ABC. So what I would say is angle ABC is a right angle. What's the reason that it's a right angle? Definition of perpendicular. Remember, whenever you have some definition that you're using, that's always going to be your reason. So if you have no idea what you're doing, you could always kind of fudge your way through at least the first step. Whatever your given is, it's probably the reason here. Usually is. Okay? So you start with that. Now, what does it say about right angles? I think this is the one we talk about, whether there's one right angle or two right angles, I believe, right? Well, here we have just one. I think our footnote said that if there's just one angle, to say that it adds up to equal 90, correct? So what equals 90? Angle ABC equals 90, which means, what did we use? Definition of a right angle, very good. Is ABC a big angle or a small angle in this case? Okay, all right.
It's a big
Yeah.
angle is what we're talking about.
Yeah, in this case here, what is ABC, I should rephrase that then. What is ABC made up of? Two small angles, which ones? 1 and 2. So could I also say then that angle ABC, angle 1 and angle 2? Two smaller angles add up to equal a larger angle. What's the reason? Angle addition. Hey, do I have two things that are equal to two other things? Which means, what do angles 1 and 2 have to add up to equal? 90. Because of, you just said it. Substitution, yes.
Oh, that's right.
Substitution is like an angry word to write down on a smartboard. Roll it. Have I fully utilized that whole first given statement? That first one, yeah, because if you think of what all we had here is we were given the perpendicular, and just going through the list of what we had via our diagram, we've kind of listed out everything we can from that first one, which means I go to my next one. 2 equals 3. And what can I do now? They're the same, so then what can I say algebraically? What else? You can, but what are we trying to prove? That what equals 90?
Angle 1, 3.
Angles 1 and 3 add up to equal 90. But I have angles 1 and 2 equal 90, but I also know that 2 equals 3. So what can I say? Substitution again, very good. Via substitution, angle 1 and angle 3 equal 90. That's how so many of these things work, guys. Is that you're setting up using a definition, you're rewriting it in terms of angle addition or segment addition. You're probably doing a couple of substitution steps saying that something's equal to something else. And then it's just a matter of finishing out whether you finish with congruent or finish with an equal, or they add up to 90, something along those lines. They might even actually say prove that 1 and 3 are complementary. Well, by definition, are these two complementary? So we could say that you could have done that as well. There's little things that you can do with this, but that's kind of the basic idea. Bless you. Well, go for it. Follow, bless you. Follow your progression. Linear pair is on there. It tells you exactly what to do. Everything is there for you. This is another very, very basic idea. Yes, ma'am. Okay. Take a few minutes. We'll check it here in a second. Ladies and gentlemen, this is not going to bode well if you can't follow your own directions. Angles 1 and 2. All right, linear pair. Given. According to your sheet, the very next thing it says to do is say that they're supplementary. So you write down angle 1 and angle 2 are supplementary. Reason, definition of linear pair. The very next step after that says to write down that they add up to equal 180. So, angle 1, angle 2 is 180. Definition of supplementary. If you could not get this far, you really need to remember how to read, because it was quite literal right off the thing. And I mean that jokingly, but it's on their sheet of paper telling you what to do. You follow it. Fill in the blanks. That's all it is. Okay? Is there anything else that I can say about angles 1 and 2 now?
No.
Nope. I go to the next statement. Angles 2 and 3 and 4 are also 180. It's given to me, which means, do I now have two things that equal the same thing? We have two things that equal 180, don't we? Which means those two things have to equal each other. It's the same steps.
My card's gonna draw automatically from this.
Substitution. You get two things that equal the same thing. Both equal to 180. Set them both equal to each other. Okay? After that, what do they have that's the same on both sides? Angle 2. How do you get rid of it? Subtracting the same thing on both sides of the equal sign is called?
Subproximal.
Very good. So angle 1 equals angle 3 plus angle 4. So now if you go back and think about what did you have to come up with on your own in this proof? You really only had to come up with 2 steps on your own. Guys, enough, please. The first thing you had to come up with on your own was that. Everything else, these first 3 steps, were right out of a progression. You read it right off your sheet. This next one was given to you. So the only thing you had to recognize right away is that they equaled each other. And it tells you that here and here. They both equal the same thing. After that, you'll notice that they have the same thing on both sides. How do you get rid of it? Via subtraction. So you only had to come up with 2 steps out of all of this on your own. That's the idea of these sheets. That's the idea of having those reason banks. So you knew what you're doing. It told you exactly what to do. There was no skipping of steps just saying that they add up to 180. We put it in a sequential order of supplementary to 180. Okay? The reason we do that is because sometimes you have to go backwards. We needed that extra step to go backwards. That's all. We haven't gotten to that point yet, but in due time, we should get to it. Okay? So you only had to come up with 2 on your own. You should be able to do that by now. This is the only one I would do. This one. Here's another one that's very similar to the segment one we did beginning of class. It's very, very similar to the one we did with segments, but in this case they are angles. Okay? As you start to write this out, they're giving you that. They want you to show this.
Oh,
Yes, ma'am.
is that where you have to show like the middle, like that it's there?
That's exactly
Oh,
it.
okay.
Now, when you do that, obviously we're going to have to add something together. When you add stuff together, whether they are segments or angles, in this case angles, do you have to be in congruency or equality? Equality. All math, if you will, add, subtract, multiply, divide, that kind of stuff, is always going to be in equal. So the first thing we're going to do is switch this to equal. So switch it to equal. You okay with that? Now, just like you were saying, we have to now define that middle wedge is there. Exactly like we did with the segment. How do you define that the middle wedge is there? You set it equal to itself. That wedge is CBD. You are yourself, you are equal to yourself, is what property? Flexing, very good. So if I have 4 equals 4 and 5 equals 5, why does 4 plus 5 equal 4 plus 5? What am I adding to both sides? 5. Did I add to both sides with an equal sign?
Yeah.
So isn't that the same thing with just a whole bunch more letters?
Yeah, no, it's ugly.
It's the same thing. It's the exact same thing. A, B, C. There's your add prop equal. Yeah, they're all the same. Look at this one. Reflexive, add prop equal. Hey, isn't that the same thing we're doing right now?
I have a question. Like on this, since it's like stuff is congruent, should we congruent like all like?
No, because whenever we do math, we have to.
Matthew? Montero?
They're towing your car.
I don't have a car.
They're towing your bike.
I don't have a car.
I got the
They're
bonus.
kicking your dog.
That's what it is.
It's like a 7 number.
So in this case here, notice they're all kind of the same thing over and over and over again. Do I have what does angle ABC plus CBD? Hold on a second, Matt.
They're lying.
That's 4.
Can you so why is it not?
What's that?
Why is it not?
What are you changing?
They shouldn't have given it.
We change it at the end. The reason, when we get into this stuff here where we're adding things to both sides of an equal sign, because we knew we were going to have to do that eventually with segment addition, or angle addition, those are all done with equality. They're not done, there's no angle
So is that why you
congruency.
switched it at the beginning?
Yep,
Okay, because I didn't do that.
gotta switch it. None of those properties deal with, all those add properties and stuff, they're all over equal. Nothing's over congruency. Everything's gotta be in equal to do that. So now we know that ABC plus CBD equal a bigger angle. What's the bigger angle? ABD. So two smaller angles add up to equal a larger angle is what? Yeah, it's angle addition. Same thing again for the next one. and that one was what they call it, CDE. So we went with add prop equal to get the two smaller angles on both sides. We rewrote the two smaller angles as a larger angle twice, which means the two smaller angles that were equal to each other, that means that the two larger angles have to be equal to each other. What's wrong? CBD? E, that's the one, that's the big angle. Because I was remembering that that's what it wanted me to show eventually anyway, and I have that. I'm just using the letters that they wanted. That's all. Do I have two things that are equal to each other? Are those two things equal to other things? Which means those other things have to be equal to each other because of, hey, this is the same thing. What do you think the last step is then? Is it one? Very good. Make them congruent. Now guys, I'm trying to make this as super obvious as possible. These aren't supposed to be difficult. Because if you go, once again, if you go back and forth from reading what you have on your sheet versus what you have to come up with on your own, if you just recognize the idea that when you have two outer pieces that wind up with a middle overlap, this is the same proof whether it's a segment or an angle. You're doing the same stuff. Whether or not it's substitution things that we had earlier. That's all it is, guys. Follow the progressions. I have 4 of these for you for tomorrow, okay? Again, I cannot stress enough to have your reason banks, progression sheets, your notes all in front of you because the answers are there. Yay! Yay!
Make up the credits. Oh, you're so popular. Why people wait? We did 3 years. We took algebra twice. We done.
So, real fast, give you guys a hint. Never mind.
Wait, is there?
It's coming up. It's passing up. Come on, guys. Pass it up. Have a good one, guys. See you tomorrow. The sheets are coming up. There's always time. I would have stood at the door. You too. All 4 of them, please.
Do you have an extra packet from the one that was due today?
I don't know. What's that?
I didn't forget to send.
I don't know if I have any more of those. Beyond. Oh. Thank you. You're welcome. This one here?
Which ones do I have to do?
Front, this top one, and then the last one. No problem.
I swear I had a water bottle. Also,